Welcome, dear students, in the third video of refraction of light. In this video, I am going to explain about refraction of light through a glass prism. So let us start. Let us first know what is a prism. A prism is a homogeneous transparent medium bounded by 5 plane surfaces with a triangular cross section. Let us see in the figure. As this is a figure, in this if you will see, the first surface is the bottom, that is B, E, F, C. So bottom is the first surface. If you will see, the second rectangular surface is A, D, F, C. Second surface. Third rectangular surface is just opposite, that is A, D, E, B. That is the third rectangular surface. And two triangular surfaces are there. That is, the first one is A, B, C, and second one is D, E, F. That is the triangular cross section. Now, so this is prism, a triangular prism having 5 faces, 5 surfaces, 2 triangular and 3 rectangular. Now let us see how the refraction takes place through a glass prism. So let us start this. For that, we will first draw a triangular prism. Let us see. Let A, B, C is a glass prism and a ray of light incident on this rectangular face. Suppose AB is or PQ is a incident ray. Now this ray, if there will be no any glass prism, then this ray will follow a straight line path as I am drawing with a dotted line. But as we know, the light is traveling from air to glass, rarer medium to denser medium, so it will deviate from its original path. So to show the deviation, we will draw a normal at point Q. So normal, that is perpendicular to the face. Now as we know, the ray is traveling from rarer to denser, so it will bend towards the normal. So bending towards the normal, and it will not follow this path, it will bend in this way. Suppose it strikes PQ at R point. At this point, if you will see, the light is traveling from denser medium to rarer medium. So again the medium is, optical medium is changing. So we will draw one more normal at point R, and this is the second normal where we will draw. Let us see, the light is traveling from denser to rarer, so it will bend away from the normal. So it will not go straight, it will bend away from the normal like that. Suppose RS. So let us see what are the points. PQ is incident ray, QR refracted ray, and RS is called the emergent ray. Now if we will draw back this emergent ray in the backward direction, let it meet at point M to the direction of incident ray. Then the angle, this angle is called the angle of deviation, and we used to denote it with a Greek word delta. So let us define what is the angle of deviation. The angle between direction of incident ray and the emergent ray is known as the angle of deviation. And this angle, angle A, is known as the angle of prism or prism angle. Let us derive a relationship between I, that is angle of incidence, A angle of prism, delta, deviation, and emergent angle. So let us find these points. So A angle of prism, delta, deviation, and the angle between incident ray and normal is known as the angle of incidence I. Let this angle is R1, this angle is R2, and the angle between emergent ray and normal is known as angle of emergent. So I, E, A and delta, we will find the relation, or we can say determination of angle of deviation. So let us derive the determination of angle of deviation. For that, we will first consider this ray is traveling straight and it bends. So let this angle is delta 1, and this angle, let us consider it is as delta 2. So first, in triangle MQR, if we will see, then delta is the exterior angle. So we can write delta is equals to delta 1 plus delta 2. As we know, the exterior angle is the sum of two interior angles. So this we can write. Now if we will see this delta 1 as this red line dotted and this blue line, this angle is I, so vertically opposite angle should be I, means we can write I is equals to R1 plus delta 1, or if you will write delta 1, then we can write I minus R1. So at the place of delta 1, we can write I minus R1 plus, if delta 2 similarly we will find, then in this case we can write E is equals to delta 2 plus R2. If R2 we will bring this side, so we will get E minus R2 is equals to delta 2. So at the place of delta 2 we can write E minus R2, or we can write it as delta is equals to I plus E minus R1 minus R2, or we can write delta is equals to I plus E minus, we can take common, so R1 plus R2. So this is one relation for finding the angle of deviation. More if we will say, then let us join these two and write it as point N. So what we are finding in this, if we will say a rectangle or a quadrilateral A, Q, N, R, A. So a quadrilateral it is. As we know, in quadrilateral, the sum of angle A plus angle AQN, that is this angle, plus angle N plus angle this angle, that means NRA, is equals to 360. We know the sum of all the angles is 360 in a quadrilateral. So we can write A plus, this is 90 degree, plus angle N, we don't know, let it be write as angle N, plus this is also 90 degree as perpendicular, so 360, or we can write angle N is equals to 360 minus this and this 180, that side, minus angle A, or we can write angle A is equals to we can write angle N is equals to this much, and angle N is equals to 180 minus angle A. Now if we will see in this triangle, now look at that, in triangle Q and R, if we will see, the sum of three angles is 180 degree, so we can write R1 plus R2 plus angle N is equals to 180, or R1 plus R2 plus 180 minus A is equals to 180. We have just put this value in equation number 3. From equation 3 we substitute this value n. So we will get angle A is equals to R1 plus R2. Now substituting this value in equation 2, we will get from equation 2 and 4, if we will see, then we can write delta is equals to I plus E minus A. This is the relationship between angle of deviation, angle of incidence, angle of emergent and angle of prism, or we can say it is the determination of angle of deviation. Now, so this all is about how the refraction takes place through a glass prism. Now we will see what are the factors on which the angle of deviation depends, or we can say factor affecting the angle of deviation. So let us start. The first factor that affects the angle of deviation is I, that is angle of incidence. If we will draw a graph between angle of incidence and angle of deviation, so let us first see how the graph we will get when we will draw between angle of deviation and angle of incidence. For that we will take two axes. Let this side I am indicating deviation delta, and along x-axis we indicate the angle of incidence. So if we will draw a graph, we will get a graph like this. So what this graph indicates? It indicates that with increase in angle of incidence, the angle of deviation decreases till a minimum value, and then after again on increasing the angle of deviation, on increasing the angle of incidence, the angle of deviation increases at a point at which I is equals to E. That means angle of incidence is equals to angle of emergent. At that point the deviation becomes minimum, that is delta m, or we can say minimum deviation. So for minimum deviation we having two conditions. The condition one is I is equals to E, and second one is R1 is equals to R2. That means these two angles becomes equal. So as we get the formula, that is delta is equals to I plus E minus A. So if we will go with this formula, so what we can write from this? We can write delta is equals to now delta m, that is minimum deviation, I is equals to E, and R1 is equals to, or let it be this only. So by that formula, that means deviation formula, if you will write, then delta m is equals to, we can write I plus, at the value of E we can again write I minus A. So we will write it as delta m is equals to 2I minus A. So it is the one relationship, or it is the formula for determination of minimum deviation. So this is how the deviation depends on angle of incidence. Let us see the second factor that affects the angle of deviation. The second factor is angle of prism. So angle of deviation increases with increase in angle of prism. Now let us see the third factor. The third factor is refractive index of the medium. For a given angle of incidence, the angle of deviation increases with increase in refractive index of the medium. And the third, that is the wavelength or the color of the light. So the last factor is wavelength or the color of the light. As we know that the wavelength of as the wavelength increases, so refractive index decreases. So wavelength increases, refractive index decreases. That's why, as we know, the red color having the maximum wavelength, that's why it deviates least, and violet deviates the most. So four factors are there. Angle of incidence. So on angle of incidence, how this deviation depends, I already explained. Second factor is I said the angle of prism. So angle of deviation increases as the angle of prism increases. Third factor is refractive index of the medium. So for a given angle of incidence, the angle of deviation increases with refractive index. That means as the refractive index will be more will be the angle of deviation. And fourth factor is wavelength. So for red color, minimum deviation, as red color has the maximum wavelength, and violet color deviates the most as it having the minimum wavelength. Thank you, students. Thank you for watching.